In this topic, we will discuss the following subtopics: production of cathode rays, cathode ray tube, properties of cathode rays, CRO and TV tubes, and uses of CRO. Introduction. In this topic, we will look at how gases at low pressure start to conduct electricity steadily in enclosed tubes and movement of electrons in evacuated tubes. Production of cathode rays. By heating a metal to a high temperature, electrons can be emitted from its surface. This process is known as thermionic emission, and the electrons so produced are called thermions. A stream of fast-moving electrons is called cathode rays. Play the animation by clicking on its play button and observe what happens. Observation. When air is pumped out, initially there is no effect, but as the pressure decreases to a few millimeters of mercury, thin streams of luminous gas appear between the cathode and the anode. Further reduction of pressure causes the tube to fluoresce. Explanation. Some kind of radiation proceeds in straight lines from the cathode C towards the anode A and consists of fast-moving electrons shot out from the cathode with high velocity. The released electrons are repelled by the negative cathode and attracted by the anode, hence moving at high velocity. Cathode ray tube. The cathode ray tube is used for generating cathode rays. The animation below shows how the cathode ray tube is used to produce cathode rays. Click on the play button and observe. Observations. The millimeter pointer deflects slightly, indicating that current flows of the anode to the cathode. Explanation. When the cathode is heated from the low tension source of about 6 volts, its temperature rises and thermal electrons are emitted from its surface. The emitted electrons are repelled by the cathode and further accelerated by the anode at positive potential. The cathode is coated with barium or strontium oxides to increase supply of electrons. Electrons can reach the anode without hindrance or loss of energy as there is a vacuum in the tube. Properties of the cathode rays. The properties of the cathode rays can be displayed using a cathode ray tube. Some of them are outlined using some illustrations and others are animated. Play the animation below and observe. Observations. The image of the cross is projected onto the fluorescent screen. The paddle wheel starts rotating. The cathode rays are seen to deflect in an arc towards the North Pole. The rays are deflected towards the positive plate in an arc. The particles of gas become ionized or charged and move towards the positive plate. Then, the photographic plate is fogged. Observations. The image of the cross is projected onto the fluorescent screen. The paddle wheel starts rotating. The cathode rays are seen to deflect in a curve towards the North Pole. The rays are deflected towards the positive plate in a curve. The particles of gas become ionized or charged and move towards the positive plate. The photographic plate is fogged. Explanation. The cathode rays move in straight lines, hence the cross blocks some of them as the rest continue in their path. This forms a shadow on the screen. The cathode rays move with high speed, hence possesses kinetic energy, which pushes the plates of the paddle wheel, making it to rotate. The deflection shows the particles have small mass and are negatively charged. The deflection towards the positive plate indicates they are negative. The ionization confirms that the cathode rays possess mass and energy and are charged. The fogging of the photographic plate shows the rays possess high energy and hence move at high speed. The cathode ray oscilloscope. It is a device that uses cathode rays to display waveforms and is used to study their properties on a fluorescent screen. Play the video below to see a working.
An oscilloscope measures voltage and displays it on a graph. And we have two scales. We have the amount of voltage, which is on the vertical axis, and then the amount of time on the horizontal. There's a lead here, and here's the lead that you'd actually put on whatever you're trying to measure, and then a little ground clippy. Quite a few knobs and buttons on this thing. This one is the power and intensity, so if I want to make that brighter, I can. Here's my vertical position, so I want to zero it right on that center line. Then a horizontal position here, just try to get it about in the middle, and then call that good. Room here for two channels here, so we have voltage ranges, which is our our vertical axis, and then one time scale that both channels have to share, which is our horizontal axis. If that didn't make sense, just hang in there. I think it's going to start making sense real soon as I start demonstrating how we can measure voltage. So the first thing we need to do is set our time scale. So if we look over here, I'm on 1 volt. Let's go up to 5 volts. So if I'm on the 5 volt scale, every line should be 5 volts. I have a 9 volt battery here, so if I hook it up, it should go up on the positive almost to this second line. And what do you know? Exactly. So if you go above the center line, it's positive. Now if I reverse this battery, I can make this line go down. You can see that I have 9 volts negative there.